This is a video for OCR Pure Core Mathematics, Hyperbolic Functions 1, Introduction, 1.4, Differentiating and Integrating Hyperbolic Functions. We can use the definitions of cosh x to differentiate it. This thing here will become d by dx of e to the x plus e to the minus x all over 2. And when I differentiate that, let's pull the half out the front, differentiate e to the x, I get e to the x, and differentiate e to the minus x, I get e to the minus x, but I get an additional minus sign coming in. And so this is equal to sinh x. So differentiate cosh x, I get sinh x. And there's the confirmation of that. Now just think for a minute what would happen if we started with sinh x. How would this working change? Well, this would have a minus sign instead of a plus sign. And when I differentiate the e to the minus x, the additional minus sign coming through would make this a plus, and so I'd actually get a result of cosh x. And there's the confirmation of that. So if we differentiate cosh x, we get sinh, and if we differentiate sinh, we get cosh. There's no sign changes, and of course for integration we get exactly the same thing. Integrate sinh and we get cosh, integrate cosh, we get sinh. How could I use that here? Well, I could just differentiate this using the products rule. So f dash x is going to be 2e to the 2x cosh x plus e to the 2x sinh x. And that might be the form that we need the answer in. But we might be asked to convert it using the e to the x forms for cosh x and sinh x. Let's see how that works through. So I'm going to get 2e to the 2x, e to the x plus e to the minus x, all over 2, plus e to the 2x, e to the x minus e to the minus x over 2. Now, if I pull out an e to the 2x over 2 for a second, I'm going to get 2e to the x plus 2e to the minus x plus e to the x minus e to the minus x. And so I get e to the 2x over 2, 3e to the x plus e to the minus x. Think of this as e to the x squared. I can pull one of those into here, and so I can get that as e to the x over 2, 3e to the 2x plus 1. And again, that might be the form that we're asked for, but both of these are perfectly acceptable. There's that working tidied up for you. The left-hand side shows you using the products rule and working down to here. On the right-hand side, we've manipulated the original function, substituting in the e to the x form, and then differentiated that e to the x form through here in the normal way to give us the same final result. What about integration? We're asked here to find the exact area under the curve between 0 and log 2. Well, that area is just going to be the integral between 0 and log 2 of sinh 2x dx. If I integrate sinh, I know I just get cosh, but I've got a 2x in here, so I just need to be a bit careful. I'm going to get cosh 2x, and I'm going to get a half of cosh 2x. And that's between 0 and log 2. Now the question said exact area, and that is sometimes code for you may not need to use your calculator. You can of course use your calculator to calculate the exact value here, and that's perfectly okay, but for the exact area we may be able to do it without. Let's have a quick look at cosh 2x then. We know that cosh 2x is equal to e to the 2x plus e to the minus 2x all over 2. If I stick in log 2 then, well, the cosh of twice log 2 then is going to be e to the twice log 2 plus e to the minus twice log 2 all over 2. Think of this as e to the log 2 all squared, and we're just going to get 2 squared, which is 4. So this thing is 4 plus, this is 1 over 4 all over 2. And so this is going to give me 4 plus a quarter is 17 over 4. That's going to give me 17 over 8. And similarly, the cosh of 0 is just going to be 1. We've actually seen in a previous video that the graph goes through 0, 1. So we do know that cosh 0 is equal to 1. So going back to the evaluation of my area then, I'm going to get a half 17 over 8 minus 1. 17 over 8 minus 1 is 9 over 8, so I'm going to get 9 over 16 as my final result. There's that worked through a little bit more tidily for you, and here confirmation of the values at the limits and the final result. That was the last video in this sequence, Hyperbolic Functions 1, Introduction.